The planning rooms of Allied Supreme Headquarters in early 1943 buzzed with arguments that sometimes devolved into shouting matches between officers representing different nations and service branches. Operation Overlord, the proposed invasion of Nazi-occupied France, faced a problem so fundamental that some planners privately doubted whether the assault could succeed at all. The beaches of Normandy presented a nightmare scenario for naval commanders tasked with delivering thousands of troops under fire. Strong currents, shifting sandbanks, and German fortifications created conditions where even minor navigation errors would scatter units and turn carefully planned assaults into chaos. British naval officers presented proposals involving elaborate systems of navigation, buoys, and marker vessels, but each solution created new problems. Buoys could be swept away by currents or destroyed by German fire before main assault waves arrived. Marker vessels would draw concentrated enemy attention and required crews willing to sit stationary under bombardment. American planners suggested using aircraft to mark beaches, but low visibility and anti-aircraft fire made aerial marking unreliable. The discussion circled endlessly through variations on flawed concepts, while the calendar advanced toward timelines demanding firm decisions. Into this stalemate walked a Canadian engineer carrying blueprints for what he called a simple solution, assembled from materials already in Allied supply chains. The officers who first reviewed his proposal responded with skepticism bordering on dismissal. Canada, in the minds of many Allied planners, contributed manpower and resources, but not technical innovation. The stereotype of Canadians as farmers and lumberjacks playing at warfare persisted even among supposed allies who should have known better after years of fighting alongside Canadian units. The device proposed seemed almost laughably primitive compared to the sophisticated navigation systems being discussed. It consisted of a floating platform anchored to the seabed, equipped with a powerful light visible for miles, powered by batteries that could operate for hours without surface attendance. The concept was so straightforward that multiple officers asked what they were missing, assuming hidden complexity must exist somewhere in the design. When assured that the system was exactly as simple as it appeared, reactions ranged from incredulity to outright mockery about colonial ingenuity, solving problems that had stumped trained engineers. Yet, something about the proposal caught the attention of Admiral Bertram Ramsay, the British officer responsible for naval planning of the entire invasion. He recognized that complexity had become the enemy of solutions, that elaborate systems failed precisely because their sophistication created multiple failure points. The Canadian device, which would later be designated as Navigation Beacon Mark I, offered reliability through simplicity. If it worked as promised, scattered across the invasion beaches, it could guide thousands of landing craft to precise locations regardless of weather, darkness, or enemy action. The question was whether anyone would take a colonial solution seriously enough to test it before dismissing the concept entirely. The Canadian engineer who proposed the navigation beacon was Lieutenant James Richardson, though that name, like much else in this account, represents the collective effort of dozens of officers and technicians whose individual contributions merged into institutional achievement. Richardson had served in the Merchant Marine before the war, navigating the treacherous waters of the North Atlantic where fog and storms made visual navigation impossible for days at a time. He understood intimately the challenges of guiding vessels to specific locations when natural landmarks disappeared and dead reckoning became guesswork. His experience taught him that simple, robust systems outperformed complex ones when conditions deteriorated and stressed. Crews needed tools that worked without requiring constant attention. The design emerged from Canadian naval research facilities in Halifax, where engineers had been developing improved systems for convoy escort operations. The Atlantic battle against U-boats demanded constant innovation in detection, communication, and navigation technologies. Canadian contributions to this effort often went unrecognized by larger Allied partners who assumed technological advancement flowed primarily from American industrial might or British scientific establishments. Yet the Canadians had carved out expertise in specific niches where their unique operational experience provided advantages. Cold weather equipment, navigation in poor visibility, and systems designed for reliability over sophistication became specialties born from necessity and refined through hard experience. The beacon itself consisted of a floating platform, approximately 10 feet square, constructed from welded steel and fitted with flotation chambers that kept it stable even in rough seas. Anchored to the seabed by heavy chains, the platform carried a powerful electric lamp powered by large-capacity batteries housed in waterproof compartments. The light could be adjusted for brightness and fitted with colored filters to allow different beacons to be distinguished from one another. Most critically, the entire system was designed for rapid deployment, requiring only a small crew and minimal equipment to position each beacon. Dozens could be deployed in hours, rather than the days required for more elaborate marking systems. Testing began in the cold waters off Nova Scotia, in conditions deliberately chosen to replicate the challenges of the Normandy coast. Canadian naval vessels practiced deploying beacons in darkness and rough weather, then used them to guide landing craft to designated beach sectors. The results exceeded expectations as Coxswain's reported that the beacons provided clear reference points visible from miles away that allowed precise navigation even when other landmarks disappeared. Accuracy improved dramatically compared to conventional navigation methods, with landing craft consistently arriving within yards of intended positions. The system proved remarkably resistant to weather, with beacons continuing to operate through storms that would have destroyed more delicate equipment. Despite successful testing, convincing Allied command to adopt Canadian technology required navigating institutional prejudice and bureaucratic resistance. British officers questioned whether systems tested in Canadian waters would perform adequately in the Channel. American planners expressed concerns about relying on unfamiliar technology not produced by established defense contractors. Some objections masked simple nationalism, reluctance to acknowledge that significant innovation could emerge from junior partners in the alliance. The Canadians persisted through political channels and direct demonstrations, gradually building support among officers who recognized that invasion success mattered more than national pride. Admiral Ramsay's endorsement proved decisive in overcoming institutional resistance to the Canadian navigation system. His reputation and position gave him authority to mandate technologies regardless of origin when he judged them essential to mission success. After personally observing demonstration trials in early 1944, Ramsay declared the Canadian beacons would be deployed across all invasion beaches and ordered immediate production of sufficient units to mark every designated landing zone. His decision triggered rushed manufacturing as Canadian facilities worked around the clock to produce hundreds of beacon units, while training teams prepared to deploy them in the hours before the main assault began. The production effort revealed Canadian industrial capabilities that often went unrecognized by allies who thought of the nation primarily as a source of raw materials and agricultural products. Factories in Ontario and Quebec that had converted to war production proved capable of delivering precision equipment to demanding specifications and tight timelines. Welders, electricians, and technicians who had learned their trades in peacetime industries applied their skills to military requirements with results that matched or exceeded output from larger Allied manufacturers. The beacons began arriving in Britain by March 1944, stockpiled in secure facilities, while invasion planning entered its final phases. Training for beacon deployment became intensive, as specialized teams learned to position the devices quickly and accurately in darkness under simulated combat conditions. Each beacon had to be anchored precisely at predetermined coordinates to create the navigation grid that would guide landing craft. Positioning errors of even a few hundred yards could misdirect entire waves of troops with potentially catastrophic consequences. The teams practiced obsessively in British coastal waters, refining techniques until they could deploy a complete beacon array in less than 2 hours, working from small boats in total darkness. Their Canadian instructors emphasized that lives depended on accuracy, that every beacon positioned incorrectly meant soldiers landing in wrong sectors facing unexpected defenses. The Germans remained entirely unaware of the Canadian navigation system being prepared for deployment against their Atlantic Wall fortifications. Their intelligence services focused on tracking major equipment movements and large-scale preparations, missing the significance of relatively small devices being stockpiled in British ports. Even if German reconnaissance had spotted the beacons, they likely would have dismissed them as minor navigational aids rather than recognizing their central role in invasion planning. The tendency to underestimate Allied technical capabilities, particularly innovations from smaller nations, created blind spots that German intelligence failed to recognize until far too late. As D-Day approached, the beacon deployment teams received their final briefings and moved to embarkation points with their equipment. They would go in before the main assault, dropped by fast boats in darkness to position beacons while German coastal defenses remained on routine alert. The plan required nerves of steel and perfect execution, inserting small teams into enemy-controlled waters to place devices that would guide the massive invasion fleet following hours behind them. These Canadians would be first onto the invasion beaches, working in darkness to light the way for thousands coming after. Their contribution would remain largely invisible to the armies they guided, but without their simple invention and flawless execution, the entire invasion faced failure before the first soldier touched sand. The night of June 5th, 1944, brought weather that nearly forced postponement of the entire invasion as storms lashed the English Channel with wind and rain that tested every vessel preparing to cross. General Eisenhower made the agonizing decision to proceed based on meteorologists predicting a brief weather window, gambling that conditions would improve enough for naval operations while remaining poor enough to reduce German vigilance. In this chaos of wind and darkness, Canadian beacon deployment teams climbed into their small craft and headed toward the Normandy coast ahead of the invasion fleet. Their mission required them to navigate through rough seas, avoid German patrols, and position their beacons with precision while working in conditions that made every task exponentially harder. The teams moved in small motorboats, barely large enough to carry crews and equipment, vessels chosen for speed and low profile rather than seaworthiness or comfort. Waves crashed over bows as coxswains fought to maintain course toward coordinates, memorized during months of planning. Each boat carried several beacon units, anchors, and battery packs weighing hundreds of pounds that had to be manhandled over the side in darkness while the boat pitched in the swells. The men wore dark clothing and had blackened their faces, making them nearly invisible but also making it difficult to see each other or the equipment they struggled to deploy. Communication reduced to hand signals and whispered commands as they worked against the clock to complete positioning before German dawn patrols made their presence obvious. German coastal defenses that night operated on routine alert, their garrisons watching the storm and assuming no sane commander would attempt operations in such conditions. Sentries huddled in bunkers rather than manning exposed positions, radar operators struggled with signals degraded by weather, and patrol boats remained in harbor rather than risk the rough seas. This reduced vigilance created the window Canadian teams exploited as they crept along the coast, positioning beacons at Utah, Omaha, Gold, Juneau, and Sword beaches. A few German positions detected unusual activity offshore and fired occasional shots into the darkness. But the small boats presented difficult targets, and the defenders assumed they were observing minor reconnaissance rather than the preliminary stage of invasion. By 0300 hours on June 6th, the last beacon had been positioned and activated. Across 50 miles of Normandy coastline, powerful lights now burned in carefully arranged patterns, invisible from shore but clearly visible to approaching landing craft. The Canadian teams withdrew as quickly as they had arrived, their mission complete but their fate still uncertain as they raced to reach friendly vessels before daylight exposed them to German fire. Several boats took damage from coastal artillery that finally recognized something unusual was occurring, but all teams successfully extracted, with casualties limited to minor injuries. They had lit the path to invasion, and now thousands of landing craft carrying the largest amphibious force in history were following those lights toward destiny. The invasion fleet, approaching through the darkness and diminishing storm, relied absolutely on those beacons for navigation to correct landing zones. Coxswains peered through spray and darkness looking for the lights that would guide them to assigned beaches. The beacons performed flawlessly, their powerful lamps cutting through weather and smoke from naval bombardment to provide clear reference points exactly where promised. Landing craft corrected course based on beacon positions, adjusting approach vectors to compensate for currents and wind. Units arrived at their designated sectors with unprecedented accuracy, delivering troops and equipment to precisely planned locations rather than scattering them randomly along the coast. The simple Canadian invention had solved the navigation problem that had threatened the entire operation. As dawn broke over Normandy on June 6th, the German defenders finally grasped the scale of what was hitting them as thousands of vessels appeared offshore in the largest invasion fleet ever assembled. Soldiers manning Atlantic Wall fortifications stared in shock at the armada materializing from the storm, then opened fire with everything available as landing craft pushed toward the beaches. The fighting became immediately desperate as German resistance proved far stronger than optimistic planners had hoped, turning beaches into killing zones where men died by the hundreds in the first minutes. Yet even in this chaos, the Canadian beacons continued guiding waves of reinforcements to correct positions, ensuring that follow-up units landed where needed, rather than adding to congestion or arriving at undefended sectors. At Juno Beach, assigned to Canadian assault forces, the navigation beacons proved critical as strong currents, and heavy German fire created conditions that would have scattered landing craft without precise reference points. The first wave took brutal casualties hitting fortified positions, but subsequent waves arrived exactly where needed to exploit gaps and reinforce success rather than duplicating attacks on still defended strongpoints. Canadian units pushed inland faster than any other Allied force that day, in part because their logistics remained organized, with supplies and reinforcements arriving at correct beaches throughout D-Day, rather than piling up wherever currents happened to carry them. The beacons burned on through smoke and shellfire, impassive metal platforms serving their purpose while battles raged around them. German commanders trying to organize defensive responses found themselves hampered by the unexpected accuracy of Allied landings. Their planning had assumed that navigation difficulties would scatter invasion forces across wide areas, allowing defenders to defeat units piecemeal before they could concentrate. Instead, Allied units landed in organized groups that quickly established coherent positions and pushed inland with coordinated force. After action reports filed by German officers noted with frustration how precisely the enemy had navigated to intended beaches despite weather and defensive fire. None suspected that simple floating lights positioned by Canadian teams had solved the navigation problem that German planning had counted on to disrupt invasion cohesion. By day's end, over 150,000 Allied troops had landed in Normandy with equipment and supplies distributed across beaches with unprecedented efficiency. The beacons had guided thousands of landing craft through multiple tide cycles, their batteries proving sufficient for continuous operation throughout the critical first day. Some beacons sustained damage from shellfire or were swept from position by strong currents, but redundancy in the system meant sufficient guides remained to maintain navigation accuracy. The Canadian teams who had positioned the devices remained largely anonymous as public attention focused on infantry combat and dramatic breakthroughs, but professional military observers recognized immediately that something fundamental had changed in amphibious operations capability. The success of the navigation beacons on D-Day sparked immediate interest from Allied planners preparing subsequent amphibious operations in the European and Pacific theaters. The simplicity and effectiveness of the Canadian system made it ideal for rapid deployment in diverse conditions, from the Mediterranean to Pacific islands. Within weeks, production expanded to supply beacons for the invasion of southern France and operations liberating islands along the path toward Japan. What began as a solution to one specific problem became standard equipment for amphibious forces, a simple Canadian invention that quietly revolutionized naval operations while drawing none of the attention lavished on tanks, aircraft, and other more glamorous weapon systems. The weeks following D-Day revealed the full strategic impact of accurate navigation as Allied forces built up strength in Normandy far faster than German intelligence had predicted possible. The beacons continued serving their purpose through the critical build-up period, when logistics determined whether the invasion would succeed or stall into another trench warfare stalemate. Thousands of vessels shuttled between England and France, delivering troops, vehicles, ammunition, and supplies that sustained offensive operations despite determined German resistance. The navigation system ensured this massive logistics effort operated smoothly, even as artificial harbors and captured ports came online to supplement beach landings. Military analysts studying the Normandy campaign identified navigation accuracy as a critical factor, distinguishing this invasion from earlier amphibious operations that had suffered from scattered landings and logistics chaos. At Gallipoli in World War I, navigation failures had landed troops far from objectives and allowed defenders to concentrate against piecemeal attacks. At Anzio in 1944, units had struggled to maintain cohesion during the landing phase, despite facing lighter resistance than at Normandy. The Canadian beacons had solved a problem that had plagued amphibious operations throughout military history, allowing attacking forces to land precisely where intended, regardless of conditions. This seemingly minor technical improvement translated into saved lives and strategic success. The German High Command gradually pieced together how the Allies had achieved such unprecedented landing accuracy. Captured beacons were analyzed by engineers who grudgingly acknowledged the effectiveness of the design, despite its simplicity. Some German officers expressed frustration that their own forces had failed to develop similar systems, though the reality was that Germany had not needed such devices given their defensive posture. The discovery prompted discussions about developing comparable systems for potential future operations, but by mid-1944, Germany lacked the resources and strategic position where amphibious assault capability mattered. The beacon stood as yet another example of Allied technical superiority built on contributions from across the coalition. Recognition of Canadian contributions to invasion success came slowly and incompletely, as public narratives focused on dramatic combat actions rather than technical innovations that made victory possible. The soldiers who planted flags on beaches captured headlines, while the teams who lit those beaches remained unknown to general publics. Lieutenant Richardson and his engineering team received commendations from Allied Naval Command but remained obscure figures whose names appeared in technical reports rather than popular histories. The navigation beacons themselves often went unmentioned in accounts of D-Day, their role reduced to footnotes, if acknowledged at all, despite their critical importance to operational success. This pattern of overlooking Canadian technical contributions reflected broader tendencies to underestimate capabilities of smaller Allied nations throughout the war. The stereotype of Canada as a source of raw materials and manpower, rather than innovation, persisted despite repeated evidence to the contrary. Canadian-designed equipment often received designation as British or was attributed to Allied development in general rather than credited to its specific national origin. The navigation beacons exemplified this phenomenon, a Canadian invention critical to the most important operation of the war that most people never knew Canada had contributed. The underestimation that had initially dismissed the beacon proposal continued even after the devices had proven their worth beyond question. The long-term impact of the Canadian navigation beacon extended far beyond D-Day into the evolution of modern amphibious warfare doctrine and technology. Post-war analysis of amphibious operations identified accurate navigation as fundamental to success, leading to development of increasingly sophisticated systems, building on the principles the Canadian beacons had validated. Electronic navigation aids, radio beacons, and eventually satellite guidance systems all descended from the recognition that precision landing required dedicated systems rather than relying on traditional seamanship and dead reckoning. The simple floating lights had demonstrated concepts that shaped naval operations for decades afterward. Canadian military reputation gained substantial but incomplete benefit from the beacon's success. Professional military communities recognized Canadian technical capabilities and sought Canadian participation in post-war equipment development and training programs. However, popular understanding of Canadian contributions to Allied victory remained focused on combat units like the infantry and armored divisions that fought through Northwest Europe. The dichotomy between professional recognition and public awareness created a frustrating situation for Canadian military personnel who knew their service had provided critical innovations but found civilians unaware of these achievements. The pattern persisted through Cold War decades as Canadian technical contributions continued exceeding public recognition. The individuals involved in developing and deploying the navigation beacons followed diverse paths after the war ended. Some remained in military service, rising through ranks of an expanded peacetime Canadian Navy. Others returned to civilian life, applying engineering expertise to post-war reconstruction and development. A few became academics, teaching new generations while occasionally mentioning their wartime work to students who rarely grasped its significance. Lieutenant Richardson himself returned to merchant shipping, captaining cargo vessels across the same North Atlantic waters where he had first learned the navigation challenges that inspired his wartime invention. He rarely spoke about his contribution to D-Day, considering it simply one job among many in a war where millions had served. Historical recognition of the Canadian beacons emerged gradually through academic studies and technical histories that examined invasion planning in detail. Military historians interviewing veterans and researching archival documents pieced together the story of how a Canadian invention had solved a critical problem threatening invasion success. Popular histories occasionally mentioned the beacons, but usually relegated them to brief references rather than exploring their development and impact comprehensively. The full account remained scattered across technical reports and specialist publications rather than entering mainstream understanding of how D-Day succeeded. Modern amphibious forces training for operations in contested environments still study the Canadian beacon system as an example of effective problem-solving under resource constraints. The principle that simple, robust systems often outperform complex alternatives remains relevant in military technology development, where sophistication can create vulnerabilities. The beacons demonstrated that innovative thinking mattered more than industrial scale or technological sophistication, that a junior partner in an alliance could provide solutions that larger nations missed. These lessons transcended the specific historical moment to offer insights applicable across military and technological contexts where underestimation and prejudice obscure potential contributions. The technical specifications of the Canadian navigation beacon seem unremarkable when examined decades later, but their innovation lay in recognizing that existing technology could be recombined to solve new problems. The lamp, batteries, waterproof housing, and anchor system all existed separately before Canadian engineers integrated them into a purpose-built navigation aid, optimized for rapid deployment in hostile conditions. This systems thinking approach represented the real breakthrough rather than any single component invention. The ability to see beyond established solutions to recognize how existing technologies could serve new purposes distinguished innovative engineering from mere technical competence. Production challenges during the beacon manufacturing phase tested Canadian industrial capabilities under extreme time pressure. Factories had to produce hundreds of units to exacting specifications while maintaining output of other military equipment. Quality control became critical as any beacon failure during invasion could misguide landing craft with potentially disastrous consequences. Workers understood that sloppy welds or electrical faults could cost lives, instilling carefulness despite production. Urgency. The manufacturing effort succeeded through combination of skilled labor, effective management, and workforce commitment to supporting troops heading into combat. Canadian industry proved capable of delivering precision equipment to demanding military specifications at scale and speed. Training programs for beacon deployment teams emphasized practical skills over theoretical knowledge as crews learned through repeated exercises in conditions approximating combat stress. Instructors intentionally made training difficult, conducting exercises in darkness and bad weather while simulating equipment failures and German interference. The goal was developing crews capable of improvising solutions to unexpected problems rather than following rigid procedures that would fail under combat conditions. This training philosophy reflected Canadian military culture emphasizing adaptability and independent thinking, characteristics developed through operational experience in environments demanding constant improvisation. Allied cooperation on beacon deployment revealed tensions beneath the surface unity of anti-Axis coalition, as national pride and institutional rivalries affected supposedly objective technical decisions. British officers sometimes resisted Canadian procedures despite their proven effectiveness, while American forces adapted beacon systems to their own doctrines in ways that occasionally reduced effectiveness. These frictions remained minor compared to genuine cooperation, but illustrated how even successful innovations faced resistance rooted in factors beyond technical merit. The Canadians navigated these political dimensions carefully, prioritizing mission success over credit for their contributions. The strategic implications of solving the navigation problem extended beyond immediate operational advantages to affect German defensive calculations throughout the war's final year. Once the beacons demonstrated that Allied forces could land precisely, where intended, German commanders could no longer count on navigation uncertainty to help defensive efforts. This realization forced reallocation of defensive resources and complicated planning for subsequent operations, as Germans recognized they faced opponents capable of unprecedented amphibious precision. The psychological impact of Canadian innovation rippled through Axis strategic thinking in ways difficult to quantify but nonetheless significant in eroding confidence that defensive positions could withstand Allied assault. The post-war fate of actual beacon units deployed on D-Day followed mundane paths as most were recovered and scrapped for materials during post-war demobilization. A few found their way into museums or private collections, physical artifacts of an innovation whose importance was gradually being recognized. One beacon ended up at the Canadian War Museum in Ottawa, where it sat for years in storage before curators recognized its significance and placed it on permanent display. Visitors passing the exhibit rarely paused to read the placard explaining how this simple device had helped make D-Day possible, their attention drawn instead to more impressive weapons and dramatic dioramas. Veterans of the beacon deployment teams aged into old men who occasionally gathered at reunions where they shared memories incomprehensible to younger generations. They spoke of navigating through darkness toward enemy beaches, of wrestling heavy equipment over the sides of small boats in rough seas, of watching their beacons light up and knowing thousands of men would soon be following those lights into battle. Some expressed frustration that their service remained unknown, while other units received recognition, but most simply felt satisfaction from having done their job well under difficult circumstances. Their contribution spoke for itself in the success of the invasion they had helped guide. Canadian national identity integrated the beacon story slowly and incompletely into narratives of wartime contribution. The device appeared occasionally in documentaries and books about D-Day, usually mentioned briefly among many factors contributing to invasion success. School curricula teaching about Canadian participation in World War II focused overwhelmingly on combat units and military campaigns rather than technical innovations. The beacons remained specialist knowledge rather than common cultural property, known to military historians and naval personnel but absent from popular understanding of how Canada had helped win the war. International recognition of Canadian wartime technical contributions improved gradually as historians in Allied nations began crediting innovations to their proper origins rather than attributing them generically to Allied development. British and American military histories published decades after the war acknowledged the Canadian navigation system and its importance to invasion success. Academic conferences examining amphibious warfare included papers analyzing beacon technology and its impact on operational effectiveness. Professional communities corrected historical record even as popular understanding lagged behind, creating disconnect between specialist knowledge and general awareness. The lesson embedded in the beacon story transcended specific historical details to offer insights about innovation, underestimation, and the sources of military effectiveness. Technical superiority emerges from creative problem-solving, rather than simply from industrial scale or resource abundance. Smaller nations with specialized expertise can contribute decisively to coalition efforts when allowed to apply their knowledge. Prejudice and underestimation blind organizations to solutions offered by those deemed inferior or unimportant. These principles applied beyond military contexts to any complex endeavor requiring cooperation among partners of unequal size and status. The Canadian beacons illuminated more than invasion beaches. The final assessment of Canadian navigation beacons requires balancing immediate tactical impact against longer-term strategic and doctrinal influence. In tactical terms, the beacons directly enabled invasion success by solving the navigation problem that had threatened to scatter landing forces and create chaos during the critical assault phase. Thousands of landing craft reached correct destinations because of Canadian innovation, delivering troops and equipment where needed rather than depositing them randomly along 50 miles of coastline. This precision translated directly into lives saved and objectives achieved as units landed in organized fashion, rather than piecemeal groups vulnerable to defeat in detail. Strategically, the beacons contributed to rapid buildup of Allied strength in Normandy that allowed offensive operations to commence before Germans could marshal effective counterattacks. The logistics efficiency enabled by accurate navigation meant supplies and reinforcements arrived steadily at correct beaches throughout the critical first weeks, when invasion success hung in balance. German attempts to drive Allies back into the sea failed partly because the invaders achieved force concentration faster than defensive planning had considered possible. Canadian innovation had shifted strategic mathematics in ways that German commanders recognized too late to counter effectively. The doctrinal impact emerged over years as military establishments absorbed lessons from beacon success and incorporated them into evolving amphibious warfare concepts. Precision navigation became recognized as fundamental requirement rather than desirable enhancement, driving development of increasingly sophisticated systems. The principle that specialized equipment designed for specific operational challenges outperformed improvised solutions became standard in military procurement. Canadian innovation had validated approaches that shaped how modern forces plan and execute amphibious operations against defended shores. Recognition of Canadian contributions remains incomplete decades after events, with Beacon's story known primarily to specialists rather than general publics. This limited awareness reflects broader patterns of underestimation that persisted even after Canadian capabilities were repeatedly demonstrated in combat. The tendency to attribute innovation to larger powers while dismissing contributions from smaller nations created historical blind spots that scholarship only gradually corrects. The beacons stand as example of contribution that changed warfare, despite remaining obscure to those unfamiliar with technical military history. The simple Canadian invention that made D-Day possible carries lessons about innovation, capability, and the dangers of underestimation. Technical sophistication matters less than creative problem-solving and willingness to challenge assumptions about what is possible. Smaller nations possess expertise and capabilities that larger partners often overlook until circumstances force recognition. Prejudice blinds organizations to solutions offered by those deemed inferior regardless of merit. The beacons that guided invasion forces through darkness toward Normandy beaches lit more than immediate path forward. They illuminated principles about cooperation, innovation, and respect that remain relevant long after the specific challenges they addressed faded into history. The lights burned bright on D-Day morning, and their glow persists in lessons still teaching those willing to look beyond surface appearances to recognize value wherever it emerges.